Dyke from ThoughtWorks, who has been working on some amazing projects in the context of explainability. I got to know Hugo's work on one of the forums. Gautier had invited him to speak, and I was kind of looking at some of the things he has been building in making these tools explainable, but also kind of making it accessible in an open source setting. So we are very pleased to have you, Hugo, join our Spring School. So for people who don't know, the Quant University Spring School is a series of sessions we hold more or less every week. We have been doing it since summer of last year. And we have had more than 30 speakers who have contributed their time, and they've been generous with what they've been working on and sharing with everybody. And we have had people from 13 different countries join us every week, and they have been enjoying these sessions and also learning. So for people who are regulars, welcome. For people who are new, welcome to the family. I hope you learn a little more every week, and then keep in touch with like what's happening in the world. So today we have a couple of other announcements too, but before we get started, we've tried to follow this tradition. So if you would take a second and just type in where you're dialing in from, I'd very much appreciate it. So I'm based out of Boston, and Hugo is based out of Amsterdam. So I think we already have 2 countries covered in the world. So if you can tell me like where you're dialing in from, I would very much appreciate it. So we have Noida from India, Spain, Charlotte, North Carolina, Delhi. Anybody else? Okay, so we have Germany, we have Boston, we have Toronto, we have Amsterdam, we have historic Somerville, which is a town in close to Boston. So we have a lot of people from Boston, Calcutta, India. So I'm glad to see so many people from so many countries, especially with all the time zone differences, make it. And for people in India, our hearts go out to you. I'm originally from India, and many of my students who are joining us today are also from India. So I hope things are going to get better soon. We have gone through it, and Europe has gone through it, and we are still seeing things not fully open up yet, but it's kind of devastating to see what's happening in India. And we'll make some announcements in this regard in a second. So let me just share my screen. So I'm going to make a quick introduction, and then I'll hand over the stage to Hugo. Give me 1 second. Okay, so for people who are getting to know us for the first time, so we are based out of Boston, Massachusetts. We started in 2013, focusing on the intersection of data science, machine learning, and finance. And we've been working with various companies, helping them kind of bridge the gap between the practitioner's approach to machine learning and AI and data science, but also contextualizing it to the business use cases. And in that realm, we have been working on a lot of educational programs. We do a lot of B2B programs, and now a lot of B2C programs, partnering with Premier and other organizations. We're also working on a platform called as Q Sandbox to make adoption of artificial intelligence and machine learning products pragmatic, but also in a responsible way. So we are building out auditing tools, ways in which you can evaluate things. And that's the whole reason why I'm interested in this whole notion of model risk management, model lifecycle management, and the associated tooling which goes around which, what Hugo is working on in the context of explainability. And as I mentioned, the Spring School is going to go on till late May and June, early June. And we are going to be excited to start out with our summer school after that. And please wait for some announcements. And we are going to be offering many courses. We've been increasing the portfolio of different courses we've been offering in the context of machine learning, artificial intelligence, use of algorithmic auditing, evaluating risk in machine learning models, and also various other aspects. This session, I wanted to make an announcement. As I mentioned, there are a lot of devastating news coming out of India, and we have seen the numbers significantly go up in the last week or so. And we've been debating, what makes sense in terms of, making concrete but also actionable impact, so that for people who are staying outside, how can we potentially help people out there? And I've had multiple discussions with people back home. I have family back home. My mom lives back in India, and I make a call with her daily and check in, what's happening. But I also hear things which are terrible. My neighbors lost their parents, and some of my friends have had people in their hospitals. And as many of you know, I teach at Northeastern University, and we did a whole semester on productionizing machine learning. And one of the student teams came up with a whole end-to-end application on building out a chatbot and integrating it with a call center. And we got this idea. So, well, what in case we operationalize it to potentially help out people who may not have access to the internet, who may just have a phone and they're looking for help. So we have a group of 6 to 7 students who have finished the semester and who are technically supposed to be on vacation, but they're taking the time off their vacation. They're building out an application to help with an effort to help various aspects in India. So I'm going to give them an opportunity to talk about their project in a bit. And in addition to that, we are also going to be hosting an initiative wherein we're going to do a workshop in the next week. And all the proceeds of the workshop, it's going to be a donation-based workshop. And then whatever proceeds we raise will be going towards UNICEF. So please stay tuned for that announcement. Without further ado, I'm going to introduce you to the student team first, and let they do like a couple of minutes pitch, and then I'm going to introduce you to Ogi, and we'll start out with the workshop. So Priyanka and team, do you guys want to share your screen and talk about what you've been working on?
Yes, Professor. I'll share my screen. Can you see the screen?
Yes.
Yeah. Good morning, everyone. A warm welcome to each one of you. We are working on the project Emergency COVID Crisis under the guidance of Professor Krishnamurthy, following other teammates. We have collaborated together. So talking about a use case, the main aim of a project is to handle emergency audio calls pertaining to COVID resource crisis. As in right now in India, there are a lot of affected people due to COVID, whether they want plasma, they want oxygen and other resources. And there are also people who are up for volunteering to help those people. But there is a disconnect between these two entities due to lack of internet facilities in more in rural areas and stuff. So we are basically trying to bridge the gap and connect basically the ones who are in need with the ones who want to support the people in need. So these are our objectives, for who it's the emergency call response teams, like volunteers with relief information regarding plasma, oxygen, blood, and also medicines and stuff. What is for addressing emergency help request by connecting volunteers who will be providing appropriate information. Why? A mass of population in India does not have access to necessary resources when needed, because there is a disconnect between people in need and the available resources. We are planning to develop this use case within a week, so it could be implemented as fast as possible, where people affected in India due to COVID outbreak, and how by developing a centralized web application for efficiently connecting cloud resources and our programming skills. So this is basically just an overview of our architecture. So this a COVID affected person will make a call using one of the toll-free numbers that we will be marketing, publishing it. That will leave a voicemail, whether they want oxygen, they want plasma, they want blood, and that will be sent to a web application. Through that, volunteers will get notification, as in the user will also enter his PIN code. So based on the PIN code, volunteers with similar with the same PIN code will receive the information, and they will have the information regarding the hospitals and other resources in their area, which will be sent to the user via SMS services. So they can so the affected people can reach the right resources on time. So also, if you want to help us, there is a survey link. You can just go to the survey and give the details and just try to contribute in your way. In order to contact us, this is the email that you can reach out to us. So let us know if you have any questions.
Thanks, Sagar. Hey, can you please put the survey link for people who want to help out in any way?
Yeah, sure.
And also the email address in the chat window. So if anybody wants to help out,
sure.
your help is very much appreciated. A lot of students, there are, all the students you see are students in the Northeastern University Masters in Information Systems program. And they are going to be building out a platform, and they will be needing some help in terms of either testing or potentially also spreading the word with your network, so that we are kind of imagining that if there is someone who just has a phone and needs oxygen, they should not be standing for 6 to 7 hours in a queue. So potentially some volunteers would help out the people on the ground. Unfortunately, for people who are outside of India, there's very little you can do other than donate money. But many a times just donating money when there is a time critical thing is not the only solution. So we're trying to see how we can make an impact for people on the ground to potentially get engaged and help others. So I hope this initiative is going to help at least a few of the people who will benefit from it. And any of the support from the community to spread the word is very much appreciated. Thanks, guys. And without further ado, we will invite Ogi Dyke. Ogi, please take it away. I know we have taken some time from your planned talk, but we're enthusiastic to invite you to our Quant University Spring School. And we've also integrated the explainer dashboard into the sandbox, and I'm very excited about all the things you've been working on. So please take it away.
Okay, yeah. So I'm Uge Dijk. First of all, thanks for inviting me. And yeah, I don't mind waiting for a bit for such an important cause. I hope it's going to help many people in India. So a bit about my background. So I have a PhD in economics. I worked at university as well for about 10 years, mostly in finance. Behavioral finance was my field. And after about 10 years, I decided to leave and do other things and become data scientist. And nowadays I work at Fourkind, which is another AI consultancy, which was recently acquired by ThoughtWorks, which is a very large consultancy that's mainly focused on software consultancy. Like ThoughtWorks is about 8,000 employees. We're about 40, but we're now happy to be a part of the family. So we're an AI consultancy. So I'll just skip this stuff. You're not here to buy stuff. But one of the nice things, if you're into whiskey, we actually developed the world's first AI-generated whiskey. So if you're into AI and into whiskey, you can order this one, and you can taste how well AI can generate whiskey. Okay, so this is just a quick outline of the talk. So I'm going to first start with a bit of background on XAI or explainable AI. Like, what is it? Why would you need it? And how like, what is one way to think about it? Then, as Sri already mentioned, I developed a library that should make it easier to kind of make this explainable AI libraries and underlying solutions available to non-technical stakeholders. So even your manager could use it, or could inspect it, or regulators, or your customers or citizens, and these kind of things. So I'm going to show what is all the features of that dashboard, and then if there's time, also do a little tour on how you actually make a dashboard fit to whatever need you have yourself. So you can actually customize almost every single aspect of the dashboard if you have a bit of time. But we're going to see if we can reach there. So first off, so why explainable AI? So this might depend on like where you're actually working and for what use you're actually building your models. So if you work in government, I actually worked in government for 2 years, which is the reason why I actually developed this tool, because we were dealing with a lot of these issues. If you're in government, there's often now like some kind of watchdog that is inspecting all the government agencies and their use of AI and like the models they're using. And if there's no watchdog, the media is very focused on this and very worried on this. So if you use a model that uses inputs in a weird way or focuses on the gender or racial backgrounds or other features, there's going to be bad news. So you really want to be able to make sure that you know what your model is doing and you're able to explain what your model is doing. So if you're using a model to optimize like which citizens get which service, or like when you're fighting fraud, you're trying to detect like who's committing fraud or not, which typical things you do in a government agency, you need to make sure that how you're using your model is actually explainable, and you can explain it to the citizen and also to the regulators what you're doing. Another use case, if for example, like if you work in banking and you use machine learning for credit scoring, so you're determining which customer should receive a loan and which customer shouldn't, based on their background characteristics. Also, this is quite heavily regulated in most countries, because of course regulators are worried that you're going to use models based on where people live or their racial backgrounds or these kind of things. So this is usually tightly regulated. So if you work in this kind of industry, you kind of have to make your models explainable to the regulators at least, and maybe also to the end customers. And then finally, also in private business, if you're working in the EU, like in the GDPR, the European-wide privacy law, there is a written a so-called a right to an explanation. So the people who are affected by your models have a right to an explanation. I don't think this has really gone into the court yet. Nobody really knows what this means yet, which is something we'll get out of. We'll get to it later. Like, what does it mean? Like, what is an explanation really? But there's also a talk of new EU regulations, which are going to be even stricter. So it's going to be really hard to actually have models in production at all, it seems, from the first reports. So even like the likes of Amazon and Google aren't actually worried, like, are we able to use AI at all in the future? Because like the way it's worded, it seems like very strict. But also, like, even if you if you're not working in these sectors, but you're just worried, like, do I have a model that might have an impact in a wrong way that I hadn't really thought about? I really want to understand like what my model is doing. Is not using some features in some weird way that I wouldn't use those features myself if I had to make a decision. So I wouldn't want the model to use it in the same way. Or if you work in a private company and you use a model to optimize, I don't know, your marketing or whatever it is, it probably helps if you're able to explain what your model is doing to yourself, first of all, so you understand it, and also to your managers or stakeholders, right? Like if this model is going to affect significant revenue, it really helps if you're able to explain what the model is doing. Like if it's a black box, like one thing you can say, like, it's a black box, but but it works really well. We don't really understand it. It might break at any moment, but for now it seems to work, and that might be a hard pitch for your manager to actually approve this, get into production. So the more that you're able to show you actually really understand the model and what goes into it and how it works, the higher the chances of actually getting your model in production, which of course, if you're a machine learning engineer or a data scientist, is in the end what you're going for. So yeah, so these are some reasons. Either like you really have to make sure your models are explainable, or it's nice to have that can really help you getting your stuff into production. Anyway, okay, so you may have heard about this phrase called black box algorithms, and the idea is like you have this algorithm which is a black box, like the input goes in and out comes some decision like approve this loan or not, but we don't really know like what's happening on the inside. And this used to be true. This is less true now, I think, but still to some degrees it is true. But the reason we're using these boxes, these opaque boxes, is because these algorithms, these machine learning algorithms, are actually really good at finding patterns in the data and then exploiting those patterns to make predictions and to make really accurate predictions, hopefully, if you did your job right. But then, of course, like the worry is like what patterns it is actually finding and exploiting. So it might find that certain backgrounds are more likely to commit fraud in the training data, which might be because the training data was only collected for certain groups, for example. So you really have to wonder, like, what kind of patterns is the model actually using? And like if you have this kind of model, which might be an XGBoost model, which consists of hundreds of decision trees, which then get added up in some way, or you have a neural net with hundreds of parameters, hundreds of millions of parameters, billions of parameters nowadays. It can be really hard to explain. Okay, what is it doing? How do all the decision trees actually fit together, or all the parameters in neural net actually like generate the actual prediction? So if we're going back to what we said, so we want to make sure that the people can trust us. If you work in government or regulated industry or in private business, that your managers or your stakeholders or the regulators actually trust your model. We need to somehow open up this black box. We need to be able to explain what is this black box doing. It seems to work really well, but what is it actually doing? So we need to break it open, this black box, and explain what it's doing. First of all, to data science themselves. So if you're working on it, you should understand your own model, hopefully, and maybe to a fellow data scientists as well. That might be easy to explain because they already understand all the concepts behind data science. But you should also be able to explain your model to your manager, who might not be all technical, and to their manager, who's definitely not technical, maybe to the CEO, who doesn't understand anything about math or numbers. Well, hopefully a little bit, numbers at least for his accounting. But then you also might have some regulators, either external or internal. Like in a government agency, you actually had a regulator internally who was kind of looking out for is there any abuse with this kind of stuff. And then finally, of course, you're building stuff for customers or for citizens, so they might also have a right to an explanation, or you should be able to explain why you decided the way you decided to a citizen that asked for an explanation. Okay, so this is important. How do we do it? So first of all, so we've been talking about, okay, you need to explain your model, but this is one of the issues in kind of explainable AI. I don't think anybody really agrees on what does it mean to explain your model or your prediction. Should you be able to explain the whole model? And then, in case of random forest, with 100 decision trees, we're explaining it here are all the decision trees plotted out in a PDF of 1,000 pages, and here's the model now to explain, because it's a decision tree you can walk through. Or should you only be able to explain a single prediction? So, okay, your prediction was 80% chance of fraud based on these reasons. And then a question, how detailed should this explanation be? Again, should you show every single decision tree, or only a summary? Should you include all the factors, or only the top 5? Should this be done understandable to somebody who doesn't understand numbers that well? If you did explain your decision making yourself, so you looked at it in a case at a person and decided, is this person going to get a loan or not? And they would ask you why did you decide? You can probably give whole story. Well, on the one hand, your background is this, and I can see your education is that, but you have before you had already had other loans that you didn't pay back, and for these reasons, I think that you're not likely to pay back. So that's why I rejected it. So should this explanation also be in that form, in text form? So different ideas have different people have different ideas about this. And we'll see that most of the tools are mostly focused on simply explaining a single prediction and kind of explaining how each feature that went into the model actually resulted in that specific prediction. But usually it's every single feature, and then it's basically a table or a graph that kind of shows you how each feature added up to the final prediction, which you can really argue about. Is that really the kind of explanation people are wanting to see? But of course, it's really hard to actually automatically generate text for this kind of thing. Okay, so there are basically two approaches to explainability, as you kind of see. So one is use very simple explainable models. So if you use simple models, a single decision tree that's only 5 steps deep, you can probably walk somebody through it easily and explain, okay, we first went left and right and left and left, and here is how we ended up, and this is why the decision was there. But then, of course, like yeah, still explain like how did you arrive at this specific decision tree? Maybe linear models can also be quite simple, but also can be complex, right? If you add a lot of interactions to them, they also become hard to explain again. Yeah, when I was teaching master students, they had quite a hard time with explaining interactions in a logistic regression, for example, which is actually not that easy, and I think a lot of data scientists wouldn't be able to do it either. On the other hand, like you can have your very large model, your xgboost model or your neural net, and then try to, okay, can I explain the predictions post hoc? So after the prediction has been made, can I explain sort of how this prediction has been reached, and can I summarize the model in some ways? And then there are a few different approaches: line values, PDPs, partial dependence plots, and Shap values, which are the main ways of kind of explaining what the model is doing and how it's actually using your features to kind of generate the prediction. So those are also the main things we'll be focusing on. But I think, like, you know, if you can make a simple model that works good enough, then that's probably maybe a better approach. Of course, then the decision, like what is good enough, is up to you as the individual data scientist. Okay, so like the first of these approaches is called LIME, stands for local interpretable model agnostic explanations. And the basic idea is you have, you know, like some a complicated model with complicated decision boundaries. If you look at model in the aggregate, but locally, actually it might be quite simple. So like if you look at this graph here on the right, like this, you know, these boundaries seem quite complicated. So if you're in this region where it's red, then it's maybe positive, and if you reach where it's blue, like you would predict the negative. So, you know, globally the shape, you know, it's quite hard to explain, maybe, like how does it work? But for a single explanation, you can actually fit a simpler model based only in the neighborhood of this single data point. So if you have this data point here on this red cross, you can actually sample some data points in that neighborhood and then fit a simple model just in that local neighborhood. And then you can present that local model as an explanation. Okay, locally, like you know, within the range of your feature values, these are the effects of increasing or decreasing those feature values a little bit, and how would this affect your chance of being labeled blue or being labeled red. Personally, I find this a bit unsatisfactory. There's a lot of decision, like how local do you sample, like the kernel size. It's called, like, you know, like it is very wide, very narrow. You know, what kind of model do you fit here? A single decision tree, linear model with all the high parameters. So there's a lot of decisions you're taking, which would all be resulting in a different explanation, basically. And of course, like, you know, it really depends, you know, where you're actually starting and where you're sampling, how you're sampling around it. So I don't find this way very attractive. The nice thing is usually quite fast. So even if your model is it's quite complicated, this method is usually quite fast, which is like for some methods, for some models, the other methods are slow. So then maybe it's a reason to use this LIME if it's good enough. Another method that you often see used is our so-called partial dependence plots. So it's basically trying to explain, okay, how does the model change when a certain feature changes. So here's one of those PDP plots on the Titanic data set that you mostly probably know. So there's a chance of surviving the Titanic, depending in this case on the fare, so how much you actually paid for your ticket. And here you can see, you know, if you paid a lot, so here it is in the range of like $56 to $112. Then your chance of survival goes up, because probably, you know, you're first class, and those people are more likely to survive. However, you do have to be considerate that this ignores the correlation between features. So somebody who had paid I know $7 for a ticket, if they would have paid $100 for the tickets, probably all other features would have changed as well. For example, their passenger class. So all these features correlated, which is not really captured in these plots, but it still gives kind of some intuition of how the model uses different features globally. And then finally, this method that has emerged a few years ago called Shap, which stands for Shapley additive explanations, which is actually derived from game theory, but then a section of game theory which is called cooperative game theory, and the issue that people are trying to solve in cooperative game theory is one of the questions is, so if you're all working together to achieve a goal, and you actually reach a goal and you get a prize, how should you divide the prize among all the players? And this is actually quite complicated because everybody has a different contribution. Maybe one person had a contribution directly that helped the goal, but also helped a fellow player achieve the goal more efficiently. So how do you kind of add all these things up? So people were concerned about it in the 1950s, and it was already solved at basically 1950s. And then you can calculate formal games, the so-called Shapley values, which basically give you the contribution of each player to the final outcome. Don't know if you guys know this board game. This is basically a cooperative game that you are playing all together with other players to defeat various pandemics. So this was already released before the COVID pandemic, but now I guess their sales went up a lot. Okay, quite topical. Okay, so now you might think, okay, what does this have to do with anything? So like the mapping is, so in a collaborative game theory, they're worried about having a group of players who are collaborating in a game to win a prize, and the players are actually contributing both directly and for helping their fellow players. And then it was a result quite old by now, 1955 by Shapley, who basically proved a single optimal way to make the calculations for what is the contribution of each player to the final prize. So more recently, this was taken by Lundberg, who published a bunch of papers on this, and also developed a library that makes it really easy to kind of calculate the Shap values and say, okay, like it's actually basically the same way as when you're building a model. So you have a bunch of features that are working together through the model to kind of reach a prediction, and the features are both predicting directly maybe the outcome, but also interacting through interaction effects with other features. So basically it's the same problem. And then you can also prove that there is actually a single optimal way to calculate the contribution of each feature to the final prediction, given certain constraints of what an optimal way should look like. And then he had a bunch of follow-up papers where he basically proved that there are some fast algorithms to calculate this, especially for tree-based methods such as random forest, xgboost, etc. Okay, so this means like if you're a data scientist, like you don't have to reinvent this stuff. These papers are somewhat complicated, maybe with a bunch of math in there, but basically this stuff has been done for you. So if you're a data scientist working in Python, simply install these libraries and generate these values, Shap values, PDP plots, line values, etc. But that's you as a data scientist. And then what I mentioned, like the next step is getting your manager or your stakeholders actually to understand the model as well, actually convincing them that you understand the model and that the model is safe, and that they can actually trust the model. So that is like a challenge that I faced in my previous job, work for government. I had this kind of internal regulators that were worried about using machine learning methods. So I thought, how can I actually show them that it's actually safe? And for like one way is actually making them explore these models by themselves, because they really have trust. It's not just I'm making some plots for them and making a presentation. Let's send this one away. they can actually explore it themselves. They can take the whole day or afternoon if they want to, and if they have any questions, they can ask me. Okay, so we want to make these kind of explanations accessible to non-coders. So that is the goal of ExplainerDashboard, which is the package that I've been developing, and it's now also part of the Q sandbox. It's very nice. So the goal of this package is, well, one's open source, so like anybody else working government or wherever can use it. So there's also some commercial solutions for this. For example, Fiddler.ai has this kind of service, but I wanted to make it open source and free so everybody can use it. But so the idea is like we should make it easy for data scientists to build dashboards that are interactive, that really show how the model works, which then makes it easy for stakeholders to actually use these dashboards and simply by clicking around can get an understanding of what the model is doing. And also it should be somewhat easy for organizations to kind of have these dashboards deployed somewhere. So anybody who wants to have a look at the model, you can simply give them a URL and a login, and they can go and explore it without US data scientists having to take part of your day to make all kinds of plots. So that's a library. So it does a whole bunch of things. So it's ExplainerDashboard. So it's really trying to explain your model. So one is, explain your model performance. Of course, if you go to a manager, like, you want to show, does it even work? To answer the question, does it add value? It explains individual predictions. So you can really break down each prediction to the contribution of each feature to that final prediction. It can also explain, what happens if. So, like, if you have a feature, a gender in your data set, and if it's male, like, what if you change to female or the other way around? Or age, like, what if you change the age upward or downward? So, you can change all kind of features at the same time as well. You can kind of show like which feature go into the model, and then also like which one are the most important. So which features are the main features that the model is basing decisions on. And also you can see in general what's the relationship between certain features and the prediction. So for example, age, like, does higher age predict a higher chance of fraud or a lower chance of fraud? If you have income in your model, does higher income predict higher priority to get certain service or lower, etc. So you can kind of see these relations. And finally, I added something where you can actually show, at least for random forest and XGBoost models, you can really inspect the model itself in terms of like all the underlying decision trees. You can actually inspect those and see like the whole forest basically, and visualize those. So that really helps. What I find, people find AI scary, machine learning scary, but decision trees are not so scary. So if you can show my model is simply an average of a bunch of decision trees, and here are the decision trees, and here's the average, that already takes away a lot of fear of these models, which again might increase the chance of you actually getting your model in production, assuming that what you built is actually helpful and useful for mankind. Okay, so that was kind of my background. So I can take a brief pause here to see if there's any questions here, and then I can go to a demo to kind of show what the dashboard, how it works, how you run it, and what you can do with it.
Thanks so much, Ugi. This was very helpful. I think there are a couple of questions, and probably that's going to be cleared in the demo. So one, and maybe it's something to think about when you're doing your demo. Does the explainer dashboard work with deep learning models too? Was one question. Another question is, does it work with Spark ML models?
At the moment, the answer is no. So it works with a scikit-learn compatible model, which includes xgboost, lightgbm, and catboost, as long as you have a wrapper for those, which makes them compatible with scikit-learn, which all these libraries offer. Deep learning should be workable in principle, but it's I'm kind of assuming that your model input data comes in the form of a pandas data frame, so I know all the feature names, so I can actually assign the contribution to each feature name. So it's not so straightforward how to map that to a deep learning model, because like usually the inputs are tensors. So actually I'm working on that and kind of getting that to work. I actually was working on it this afternoon, but at the moment it's not working yet with deep learning models. Also Spark ML I haven't tried yet, actually. But if you want to try and it doesn't work and you see an error, maybe you can show me the error. But as long as the model itself is sort of compatible with scikit-learn, so it has a fit function and a predict function, then it should work.
Cool, thank you. And I'm also known to volunteer my students on initiatives which they have not really agreed upon, but then they get volunteered. So I have a whole group of students who are just taken some of my courses and they're very familiar with machine learning. So if you, and again, they're allowed to support open source efforts. So if you are interested in extending and getting leverage from some of the volunteers, please do let me know. I can pass on the message to my students. They may be happy to contribute in the summer.
Sure. So I can just show you the, there's a to-do page here, empty file here somewhere. It's not super organized, but it's there's a bunch of stuff that's,
okay.
I am planning to do. So if you want
to kick off a meeting with some of the students and they want to take one thing at a time and, could potentially support. And also goes to the community also, people who are listening in both on LinkedIn or rather LinkedIn, YouTube, and also here. So if anybody wants to contribute to this effort and making this tool more robust, please feel free to reach out to Ogi and then we should
so just open an issue and I can help with you to work it to get the code into shape. So that's so it'd be very helpful, very helpful to get any contributions there. Okay, so let's just give a quick demo. It's data science, so it's basically just fit predict, right? That's our life. So first we got some data. So this is the standard Titanic data set that probably most of you know from the Kaggle competition. So we're predicting basically whether a certain passenger survived the disaster with Titanic or not, based on their characteristics such as how much they paid for the ticket, their age, during the class, the first, second, third class, the number of siblings aboard, whether they're male or female, the deck they were located on, where they embarked in which city, and then here we have an index. We have actually the names of all the passengers. Right, so there's a data set. So then, if this is how difficult machine learning is, you simply import something and you do fit. Boom, there it's done. So you also, there's not a lot of trees in the random forest, and it's not too deep. That's why it also goes very quickly, 99 milliseconds. So if you want to use Shap, so there's a library which actually is able to calculate Shap values. It's quite easy to use if you have a notebook. So you simply import Shap. You fit an explainer, Shap explainer, in this case a tree explainer because it's a random forest model, and you use it to calculate Shap values. And so you get this kind of NumPy arrays, and then you can also visualize that in your notebook to kind of see this graph where you can see, okay, the prediction here was 0.69 apparently. So the probability of surviving was 0.69, and these are all the features that actually I could add up to this 0.69. Okay, so you can do this in your notebooks if you're a data scientist. The tool is not made for you. It's to make this easy to share with others, right? So the way you do that is you first wrap your model and a test set that you'd like to explain into an explainer object. In this case, I'm also grouping some one-hot encoded columns. So you see in your data set, there were a bunch of one-hot encoded features here. So you can also group those back together again, so it's easier to kind of read things, and also add some labels like whether what does the 1 mean, what does 0 mean, and then you can use explainer also just in your notebook. So here you have the contributions. So again, for the first row, the probability of survival was 68%, and these are all the reasons. The model, so mainly because the deck was C, which is good apparently. The fare was quite high. The passenger class was first. The gender in this case was not encoded. Embark and share book. Anyway, like all these features added up to the model thinking there's a 68% chance of survival for this passenger. You can all do all kinds of other plots like the AUC curves you can plot. You can actually inspect all the individual trees in random forest. So these are the 50 trees in the random forest sorted from lowest prediction to highest prediction. And then here you see the average. So this is actually how a random forest works. It simply has a bunch of decision trees. that it averages out. But here you're still working in a notebook, and presumably your manager is not able to do that. So this is why you can start an explainer dashboard and just run it. That's how simple it is. And then at first, does all the calculations beforehand, and then here it starts it. So here you have the dashboard running. And here on these different tabs, you basically have all the features of the dashboard that kind of answer like these questions that I have here. So first of all, feature importance is kind of this answers like how important is each feature, and we do that by the mean absolute Shap value. So the Shap value is the impact for an individual prediction of gender. So if you average that out over all observations, you get like the mean impact of that feature. In this case, gender has the biggest impact because it was 1912, and everybody is like women first in lifeboats and then men second. So if you're a woman, you're much more likely to survive. But also which deck you were on. If you were on a higher deck, high chance to survive. Lower deck, less chance. Passenger class, first class, more chance to survive, etc. So you can simply expect those. There's also another way of actually calculating importances called permutation importances. Is also shown in the dashboard. Then the question of how good does the model actually work? There's a whole bunch of ways of showing that. So you have all these different metrics that as data scientists. Actually, if you move the cutoff around, you can see them actually changing. The diffusion matrix, so everything is responsive. The classification plots also, again, depending on the cutoff, is going to change. And so there's a whole bunch of different curves and things that kind of show you how well this model is working and how good it is actually able to predict the thing you're interested in. Then we talked about individual predictions. So you can simply select any given passenger. So let's say, and then you get here the prediction, and you get the contribution. Okay, so this was the final prediction. How did each feature add up to that final prediction in this waterfall plot? And you also get a partial dependence plot. So here you have the prediction for this particular individual. But what if this person was female? But what if this person had been male? Then the prediction of survival would only been 14.5. And here you see this is the average relation between this feature and the prediction, and here are a whole bunch of individual features that could average out to this dark gray line. You can also get basically the same plot as a table, and then you can sort it in different ways, depending on what you prefer. Then you can sort of investigate. Can we find the same Mrs. again? Where was she? Well, let's do someone else. Miss Emily ROC. Then you can do what if analysis. So what if Miss Emily had been a Mr. Emily? Then likelihood of survival goes down. Deck unknown. What if deck was A? So you can kind of go around and kind of see what's the impact of changing certain features to really explain to a single customer or citizen maybe. Okay, maybe ask the question what if I'd been female? What if I'd been 50 years old? What if I'd been 20 years old? So you can answer these kind of questions. Then the other kind of thing people usually interested in kind of what is the global relationship between input features and the model prediction. So you can also do this with these Shap values. Although the interesting thing with Shap values, it's not a linear model, these kind of decision tree, these kind of random forests, there are a lot of interactions. So the fact that your age is 50 might have a different impact on one passenger than another passenger, because for maybe a 50-year-old passenger in first class, that might have a different impact than a 50-year-old passenger on third class. But you are able to see globally what's the impact of knowing the fact that age was 50. So here you can see the global pattern. So you can see the older people are, the more negative the impact of knowing the feature and knowing the age when it's high. And so this decreases. For example, if you're 6 years old, in this case for this passenger, it actually decreased the estimated chance of survival by about 7%. So you can actually click around. You can also see more detailed plots here. And also for the categorical features, you can get these nice violin plots. Then I already mentioned a bit interactions. So you can also get interaction with certain features, which usually consists of the Shap value of each feature consists of a direct effect. So how does the fact that I know your gender affect the prediction directly, and how much does it affect? So the fact that I know you're male changes my interpretation of the fact that I know that you're first class, right? So there's kind of interaction effects which are really caught by these decision trees, because the same feature can be used again and again. Here we go. So here, for example, you can see the interaction between sex and passenger class, and actually this is kind of interesting. So here you can see that the effect is somewhat attenuated for third class citizens passengers, I'm sorry. So if you're third class and you're male, you're actually slightly more likely to survive than the baseline fact that you're male would suggest. I guess, like if you're all the way down in the decks, you first need to get up to the highest level to even get on the boats. So then maybe it helped if you're strong and you're able to survive the water for longer. I don't know. So yeah, so you can find all this kind of interactions. Sometimes it's a bit hard to kind of wrap your head around, but sometimes actually quite insightful to kind of see these interactions. It also depends like which. There's interaction between like which port you embarked and your gender, for example. And then finally, you can actually visualize all the decision trees. So this is for a specific passenger. You see all the decision trees and the average of decision trees, which really helps to explain your manager, like what is the random forest, what is it? And then if you select a single decision tree, you can kind of see the single decision tree, like the path through decision trees, all the steps, all the things that affected the final decision and how it actually increased and decreased until you got to the final decision here. And then you can even generate a graph. This takes a little bit of time. Here we go. So here's the whole decision tree visualized and the path that this particular row of data or this passenger took for this decision tree. Okay, I can see we're not doing super long on time, so let me just quickly show that you can do the same thing with regression models, but yeah, you wrap it in a different explainer for regression models. And you can also give the units of what you're actually predicting. In this case, it's the dollar price of the fare. So we're predicting the fare that people paid for the Titanic. Here it is. In this case, you get these kind of plots for the goodness of fits, and obviously different metrics, but otherwise the dashboard is quite similar. And then let me just very quickly show this because we're running out of time. But it's actually like you're able to, it's like all the features of a dashboard. You can actually change. You can say like all these different components. You can hide them if you don't want them. Because what you can see here, it's quite busy, right? There's a lot of tabs. There's a lot of different components. There's a lot of toggles and things you can do. It is no longer running, so it's no longer responsive. So you can actually hide some of these tabs. You can hide individual components, and you can even hide individual toggles on a component. So actually, and you can also run these things like inside your notebook, by the way. So here we hide a whole bunch of tabs, and we only have a few components, and we hide then even like the log I on the x-axis we've hidden. So this is how you can actually customize things in a way that's only presents the things that you want to present instead of overwhelming your stakeholders with these million things. And you can even go further. So it's relatively straightforward because like all these components of the dashboard are actually their own classes, which you can reorganize yourself. So you can build your own dashboard by inheriting from the ExplainerDashboard a class, and then adding a bunch of these components with the parameters. So if you want to hide certain things or not, or you want to set a default value. In this case, we're going to start with Miss Emily ROC, and then you can make your own layout with your own text. So here I added some Quant University Spring School, some explanations of what the quant is actually doing, and then you can simply pass this kind of custom thing to a dashboard, and then if you then run it, you get like only the component that we showed with only the feature that we wanted, with some text to the side or whatever. You know, if you're a web designer, you can probably make something much nicer. And here you can see like the default value was here, Miss Emily Rock. But you can still select any other. And then the final very quick thing, you can actually combine things, combine multiple dashboards into a hub. So you can have like, if you have a bunch of different models that you want to show, you have a whole bunch of different models running in production, you can combine them into a hub. You can also do some easy login. So I said here, user and passwords, and I'm going to get a warning from Chrome that that's a very dumb password. Yes, I know. And then you get this kind of hub where you don't add that. Where you can see the different dashboards that you added. And then you can switch around between the dashboards, log out again. So this is very helpful if you have a whole bunch of models in production, and you simply add them to this hub, and then you can always show people, okay, these are the models we have, this is what you're doing. It's all transparent. Go inspect it at your own leisure. Okay, so I had to hurry up a little bit towards the end, but I hope you got the idea of kind of what the tool does and why it's useful, hopefully. So we have still maybe a little bit of time left if I have to go for dinner soon because my son is really hungry. If there's any questions, I'd be happy.
We don't want to keep a 2-year-old hungry. Yeah, okay. That's the last thing we want to do. I know how it is. So thanks so much for this. And is this possible to share this notebook? I'll share it with the meetup participants too.
Yeah. I'll also
especially with all the Quant University Spring School branding and everything, we would love to share that.
Yeah.
But I just want to let you know, I love the tool, and we actually tried out on our own too, and we integrated with the sandbox. I don't know how many people have seen the sandbox. I'll just do like a quick demo on the possibilities, and this is the sandbox, and the sandbox is basically how we can test out various products, right? So this is like, we are doing a whole course on algorithmic auditing, and I'm sharing some of this with my students. So this is like an experiment, and we're basically collated various parts of the things you got to do when you build out a whole pipeline, right? So you have, exploration, building out a pipeline, the data, the model, the explainability, the fairness, the monitoring, various aspects. And when we look at it, so just for testing, I put in your explainability dashboard, and that's how it looks. So, you basically have, I put it in an iframe and just embedded that so that when you have a model, you can kind of see it comprehensively. So you have the modeling piece, you can actually look at the code, and you can look at the various experiments, and you could say, okay, so this is the code I'm going to be running, and this is like the various things we're going to be doing. But then thinking about like the explainability piece, so you kind of integrate it as a part of the dashboard. That way, you may not see the actual underlying components, but you can actually have now a tool which you could use for what if and various other pieces. So if anybody is interested in kind of taking it for a test drive, do let me know. We're kind of still in private beta, and we would love to kind of see how we could enhance this and make it more integrated. So I think if you have like 1 more minute, we can try and answer a couple of things. So is the feature importance calculated in the same way as in scikit-learn is the question.
Well, there are two different measures of feature importance. One is based on Shap, which is not in scikit-learn. So that's simply like the mean absolute Shap value. So the bigger the mean absolute Shap value, like the higher the importance. So that's a different metric. So that's not in scikit-learn. The permutation importances are calculated a little bit different. Like it's basically the same way, right? So you take a feature and then you do the permutation. Then you see like how much does the model get worse. So I already made my own version of that before scikit-learn added it to scikit-learn. But yeah, so my implementation has a bunch of other features, for one of which is to make it easier to kind of group one hot-coded features together and get like the importance for that whole like a categorical variable at once, which is why I'm still using my own implementation instead of scikit-learn implementation. But yeah, that's basically similar as what you have now available inside scikit-learn, the permutation importances. Yeah.
Okay, so I think one other question is there are a number of things you could calculate in order to show the visualizations on them. Is there a way to access the data generated from these calculations? For example, you generate Shap values.
Yeah.
Is there a way you can access these Shap values without looking at the visualization so that we can use the Shap values for further calculations or visualization?
Sure. So let me quickly share my screen again and see if I can still remember my own API. Yeah, so you can just get, I think it's get, now I don't remember my own, no. Oh yeah, it is. Okay, there you go. Okay, yeah, so here you got like all the Shap values, like for each row of data, for each column, for example. Yeah, yeah. So there's a bunch of things. So you can look in the, like into the documentation. You'll be able to find most of these things.
Cool. Awesome. Thank you. This was very enlightening, okay, and thanks for presenting this amazing work. I know it's your open source initiative, and I hope this gets adopted by a larger community and becomes some kind of a nice way to kind of get started with explainer dashboards, but also taking it to production and kind of building out from there. So next week we have another session again on Tuesday at noon. So please join us. So for people who are not familiar, we have a whole spring school going on. So every week we basically have a session and we have Q&A. And if you like this format, or if you have any ideas for making this much more educational and entertaining, and please do let us know. We are here to work with you and see how we can make these sessions helpful for you. So next week, I have Jacopo Tagliabue, who is at Covio, and he and I, we interacted a few weeks ago, and he was one of the guest speakers in my class. So he's been doing some amazing work on automating various machine learning workflows. So he lives and breathes machine learning, and he's building out a whole architecture at Covio, which processes millions and millions of transactions, obviously. So he's talking about serverless data ops. And I know it's a little technical, but he's a very, how do I put this, involved researcher, both from the theoretical perspective, but also from a pragmatic perspective. So please join us again. That's on May the 11th from 12 o'clock. And May the 20th on Thursday, we're going to switch gears a little bit from Tuesday to Thursday. So we're going to talk about risk and AI and algorithmic auditing, and Ryan Carrier, who's leading the For Humanity project, and Shay Brown, who's a professor in Illinois, but also does work in algorithmic auditing. So they're going to be sharing their thoughts there. And we have a session on May the 25th on visualizing data by Rami Crispin. So Rami has been he's also a guest speaker at my Northeastern class, and he has been working on some really cool open source projects on visualizing data. So for people who are interested in catching up on the sessions that I've missed in the last year, so you can binge watch them at Q.Academy. We have sessions, all of these sessions are recorded. So we have more than 50 hours of lectures which are ready to go. And all the labs are on Q Sandbox. So when Ogi sends out his lab, so we'll put it on the sandbox so you can just try it out on the sandbox. Anyways, that's it for today. And I hope you enjoyed the session, and we will catch up with you again in the next week. So stay warm and stay safe, and we will see you soon. Oh, by the way, just a quick interaction. So for people who are interested in contributing to the fundraising efforts and also for the volunteering efforts next week, please watch out for a workshop we're going to be putting together. And I would love if you could spread the word, so that if there are people who can donate time or money for the initiative in India, we would love to get your support there. Thank you so much.
All right. Thank